This magnificent place we call home is just one of 8 planets in our solar system, and as far as we know, the only one that supports sophisticated life forms. Many factors have to be present for life to be possible. I'm not talking about material items like cars, houses, electronics, or clothes. Life as we know it on Earth is carbon-based and requires a certain environment to thrive and survive. These factors are in a delicate balance. When it's tipping one way or another, living things are impacted. Some thrive, some suffer, but all species in the plant and animal kingdoms are very interdependent. So even subtle shifts have ripple effects across the entire planet. That's what we're experiencing as scientists study the Earth's processes and the impacts of humankind on this delicate balance of nature. The term global warming is a widely used term to describe a variety of forces that combine to raise the Earth's temperature. While global warming as a term is widely used, many scientists argue that it is not as widely understood. Let's take a big picture approach to global warming and raise that level of understanding to a global level. Global warming, as defined by scientists, means an increase in the Earth's temperature of about 2 degrees Fahrenheit in a period of 100 to 200 years. Over the course of a single century, if the Earth's temperature were to increase even a single degree, that would be significant and get the attention of researchers. Global warming, as we've been told over the years, impacts weather patterns. Weather is what's happening outside right now. Think of it as case-by-case occurrences in specific regions. Climate looks at weather over the long term, as it has occurred in a broad geographic area. Climate incorporates long-term averages of rainfall amounts, snow totals, and average temperatures during a given season, so that we know in a broad sense, in a given geographic region, what to expect. And when we talk about long-term analysis, we're talking several hundred years long. Given the age of the Earth, 4.5 billion years, a couple of centuries is recent history. Climate changes can take tens of thousands of years. Global warming as a serious problem for our planet is a significant increase in the Earth's climatic temperature over a relatively short period of time as a result of human activities. Remember, just a minute ago, we said that if the Earth's temperature went up even 1 degree in 100 years, that would raise serious concerns. There can be natural changes in climate. Geologists and climatologists have cataloged evidence of such changes from ice ages to temperate times and back again. It can take the Earth thousands of years to warm up or cool down, and continuing climate research and monitoring helps put those changes in proper context. In the past, the Earth's climate has changed because of volcanic activity, changes in the amount of radiation from the sun, and natural changes in the chemistry of the atmosphere. The Earth's natural processes continue like a train on a set of tracks, traveling at a certain rate of speed. The big changes and significant changes come when we add human-made changes to the natural ones. A group of scientists concerned with global warming has organized the Intergovernmental Panel on Climate Change, or IPCC. The group numbers more than 2,500 scientists from countries all over the world. They meet to share study results and confer on the variety of issues that contribute to global warming. Here is a brief list of the IPCC's findings. Earth has warmed 1.35 degrees Fahrenheit between 1906 and 2006. The warming trend of the last 50 years is nearly double that of the last 100 years. The ocean's temperature has increased at least to depths of 9,800 feet. The ocean absorbs more than 80% of all heat added to the climate system. Droughts are more intense, have lasted longer, and covered larger areas than in the past. While there has not been a significant increase in the number of tropical storms, there has been a noticeable increase in the intensity of such storms in the Atlantic Ocean. Scientists believe this is directly related to the rise in ocean surface temperatures. Precipitation has increased in eastern regions of the Americas, northern Europe, and parts of Asia. Other regions, like the Mediterranean and southern Africa, have experienced drying trends, and westerly winds have been growing stronger. The scientific findings of the Intergovernmental Panel on Climate Change lead us to a discussion of the so-called greenhouse effect. Global warming is caused by an increase in the greenhouse effect. Left to its own devices, the greenhouse effect is what allows the Earth to stay warm enough for life to survive. Again, we're back to the delicate balance that, if upset, sends ripples of impact throughout all living things on Earth. The greenhouse effect happens in a series of steps. First, the sun's rays hit the Earth's atmosphere. If 100% is hitting the atmosphere, 30% is deflected back into space by the atmosphere itself and shiny things like ice sheets and snowfields. That means 70% reaches the surface and is absorbed by land, oceans, plants, buildings, etc. Not all of that energy is absorbed either. The oceans and land masses radiate heat back out into the atmosphere. Some of that heat escapes and some sticks around, getting absorbed by carbon dioxide, methane gas, and water vapor that are all natural parts of the Earth's atmosphere. Before we go any further, let's take a second to better understand all three of these important pieces of the atmosphere and how it's a good thing when they all work together to create the greenhouse effect. First, water vapor. About half of the solar energy absorbed at the Earth's surface evaporates water. Water vapor condenses when it reaches the atmosphere, creating clouds, which, when saturated, release life-giving precipitation like snow and rain. Slightly more complicated is carbon dioxide. Carbon is an element that is a part of oceans, air, rocks, all living things. Carbon atoms in the atmosphere attach themselves to oxygen atoms, creating CO2. Through photosynthesis, carbon dioxide is absorbed by plants that use the carbon as food and release oxygen back into the air. The food chain moves carbon constantly from one living thing to another. The death of plants and animals returns carbon to the ground through decay. And of course, all living things release carbon dioxide through the natural process of respiration. This is a simple explanation of the carbon cycle. Methane gas is the third component of the atmosphere that exists due to natural processes. Methane is a combustible gas and occurs naturally through the decomposition of organic material. You may have heard it referred to as swamp gas. More likely, you've encountered its sour egg smell and pinched your nose close. Ugh. Working together, these three components capture and trap heat energy inside of the Earth's atmosphere, keeping our planet warmer than it is in outer space. Without the greenhouse effect, scientists believe the Earth would look a lot like Mars, cold and without plant life. The atmosphere on Mars isn't thick enough to keep in enough heat to support the carbon cycle that's necessary for plant and animal life. So why do we hear greenhouse effect and instantly think of global warming and all the negative implications of such processes? Because human activities have been putting incredibly large amounts of CO2 and methane into the atmosphere for centuries, especially since the Industrial Revolution, roughly the mid-1800s. Manufacturing, processing, and modern conveniences are possible by burning fossil fuels. Coal and oil are our primary sources of energy that we use to make electricity. Electricity is a convenient, controllable form of energy that makes everyday life easier and more efficient. This results in more people and greater demand for things. This increases the rate of manufacture, produces larger amounts of trash, yet gives us methods to deal with the unpleasant things in life that make it nicer to live, that results in more people. You see where I'm going. It's a natural growth cycle that, whether you see them or not, has consequences. The problem? The delicate balance of the amount of carbon dioxide in the atmosphere has shifted. So too has the amount of methane and water vapor. These increases generate their own cycle, and the consequences are impacting our world and our ability to live in it. The impacts of human activity on the Earth are vast and varied. Scientists point to a rise in sea level as a significant threat. Glaciers and ice shelves around the world are melting, both because Mother Nature has her own set of processes at work and because the Earth's temperature has risen dramatically in a very short time. The Intergovernmental Panel on Climate Change estimates that sea levels rose about 6.7 inches between 1901 and 2000. The increases are expected to continue through the 21st century, impacting island nations and coastal communities around the globe. Just as an example, the Maldives, an island country of atolls in the Indian Ocean, is the lowest country in the world, with a maximum natural ground level of only 7.5 feet. Sea level rises are a constant concern here, a real-life ripple effect of global warming that impacts real lives. Ice shelves and snowfields reflect some of the sun's energy, so less surface area that's shiny will reduce that benefit too, allowing more energy to reach the Earth. Here we have yet another cycle with important and devastating implications for our planet. Ice caps melt, sea levels rise, more heat reaches the Earth, fewer icy surfaces reflect the sun's rays, more ice melts, seas rise, and so on. Imagine that each season has a dial, like a volume control. Mother Nature controls that dial, and things in the big picture remain fairly consistent, with an occasional blizzard or extended dry spell to keep up the lively chatter at the coffee shop. Now humans have more control over that dial, and the volume is constantly being turned up. Just a bit at a time, but in the big picture, it's getting loud out there. Storms get more intense, dry spells get longer, rainy Mondays turn into Tuesdays, Wednesdays, and most Saturdays, and the summer heat comes on sooner and lasts well into November. These are all red flags for climatologists who study things on a broad scale. All plants and animals exist in interlaced groups called ecosystems. This intricate network of flora and fauna rely on each other for shelter and food, their way of life, their very existence. Entire ecosystems are certainly at risk from the changing factors associated with global warming. Here, the interdependence of species is very delicate, and the slightest impact will have amazingly widespread ripples, including forced adaptation to the pressing changes or even extinction. Let's say a lake and surrounding meadow change into a dry plain with scrubgrass. The new climate of the area puts a completely different set of demands on the species that live there. Plants that rely on a certain amount of rainfall will no longer grow and prosper in the drier environment. So the rabbits that feed on those plants are forced to find another lake and meadow. The ones that stay must find the scrubgrass delicious or starve, or are attacked by a new set of predators that find life in the arid environment just right and rabbit legs tender and juicy. This is yet another cycle of life that might occur naturally over time, but is forced to extremes when that time frame is compressed by human-made climate change. Tracking climate change has its own term, carbon footprint. This is the way we measure how much carbon dioxide we've put into the atmosphere through our daily activities. Individuals have carbon footprints, so do companies, whole industries, towns and cities, even countries and continents. It's a useful term that encompasses the physical characteristics of a footprint in, let's say, sand, and the ability to measure the imprint for depth, width, and direction. The Energy Information Administration estimates that 98% of the carbon dioxide in the atmosphere comes from burning fossil fuels, oil, coal, and gas. Human activities can be measured to find ways to reduce the use. If you really want to know what impact you're having on the planet, and then strategize ways to make a positive change, get out your calculator. I mean your carbon calculator. Many versions are easily found online and will quickly put into real terms the dimensions of your carbon footprint. Calculators want to know where you live, because some states use more coal to make electricity than others, and that information, for example, will impact your results. Other questions will help generate results for individuals as opposed to an entire household, such as estimates for fuel consumption while driving and monthly electricity usage. Just remember that if you don't use real figures, your profile won't be as accurate as it could be, and therefore the drive to make positive changes might be less. In this case, more is better for everyone and the planet. While we're talking about footprints, Did you know that the Earth has an ecological footprint? This measurement compares the population's consumption of resources with the planet's ability to regenerate those resources. Scientists put the Earth's ecological footprint at 23% over capacity. To be even would be at 100% consumption, where it takes 1 year to consume the resources and 1 year for the Earth to replenish them. Using a year as 100%, 23% over capacity means it takes the Earth 14 months to replenish what humans consume in just 12. We all want to make the world a better place to live. Humans from across the globe have inspiring stories of hunger relief and poverty aid, medical help during epidemics, and the we can do it spirit to rebuild after natural disasters. In the face of climate change, it comes down to making good choices, taking advantage of new products and services, and in some cases, getting back to basics and rekindling our connection to the Earth and Her Majesty. You and I have it easy. There are so many ways to, say it with me, reduce, reuse, recycle, that from simple to complex, we can start right now. Lead by example and play a role in making the future even brighter. Use cloth grocery bags and those twisty light bulbs. Turn off unused appliances and turn up the air conditioning, turn down the heat. These are all simple strategies, and there are plenty more that add up to a big deal. Homeowners can go green by installing solar panels and improve the whole family's carbon footprint. Here's a prime example of individuals working together to make a small change that results in a significant difference. Companies can take action by taking big action. Sure, recycled paper and recycling bins for all those plastic bottles are great, but using renewable energy is a significant step in turning down the volume of climate change. We have the source, the sun, the technology, photovoltaics, and the motivation, a compelling sense of stewardship, responsibility, and leadership to do it right. Oh, and we also have plenty of available roof space that needs attention anyway. And who wouldn't like a break on their electricity bill? Forever. We're social creatures that thrive with a greater sense of belonging. Communities, towns, and cities have a great opportunity to make large-scale choices that will have large-scale and long-term benefits. Adopting clean and green initiatives that address clean water, clean air, reduced greenhouse gas emissions, and a better quality of life are becoming the norm rather than the exception. Here, too, renewable energy fits the bill, with solar energy systems that will generate all the power needed to run the municipality, freeing up already tightened budgets for improvement projects, healthcare, and other community-friendly endeavors. State governments have a unique opportunity to make renewable energy as commonplace as recycling centers. Governors and legislatures can bolster the market for solar and wind systems through tax breaks and incentives. Each state has in its history an act of boldness that changed history, that saved lives, that started a national movement. That's the kind of thinking and action that's needed to put it all in motion, a movement to change climate change for the better. As a nation, the United States has a proud history of independence and leadership on so many important issues. Starting right here at home, our government can make it more affordable to buy and install solar and wind-powered systems for homes and businesses. Incentives and tax breaks spur purchases, but also make it more affordable to build solar plants and wind farms. With all of these advances comes more use and increased demand. That leads to innovation and enhanced products and services. A very positive business cycle with its own set of positive ripples along the economic chain. When it comes to working together on this issue, nations must come to the table to talk openly, set goals and standards, and agree on the issue of accountability. It's a giant-sized dose of peer pressure. If you don't play nice, you won't get invited to the party. Of course, it's more complicated than that, but cooperation is key. Open communication is crucial, and accountability works to ensure fair play. Climate change is important, but even at a most basic level, when you embrace the Earth, its awesomeness and majestic beauty, and then think of it as part of an infinite universe, you can't help but feel inspired to take care of her.